Hello guys, Nigel here again with you, back with another video of drivel for you. This I believe is part 10, and here we're now actually getting to fit in the head. So obviously to do the head we need a new head gasket, which we got here, and we need new head bolts. So, and all very reasonably priced, I must say. You know, comparing, if you look at the Mustang, I believe a set of head bolts for that is about £1,100, I believe, I've been told. These were like 28 quid or something, I think, for all of them. So it's, yeah, it's a bargain. And as I say, if you get the Victor Wright's head gasket and engine set and shop around, you can get some really good prices. So, and also Victor Wright's is OEM quality. Although having said that, I said I changed those ladder frame gaskets, didn't I, for genuine Land Rover ones. The genuine Land Rover is obviously OEM, it's Land Rover, it came in a Land Rover packet, and they were stamped Ford. Now the Victor Rhines ones aren't. So whether Victor Rhines makes them for Ford and stamps them, the ones that go to Ford, and I have actually been ran a car manufacturing facility making brake pads, and there were loads of brake pads going into these presses, and the backing plates had all, I won't mention any for, you know, so I don't incriminate myself, but the actual backing plates had the actual manufacturer's name on. But then some of the backing plates with exactly the same pads in exactly the same press, being operated by the same person on the same day, had car manufacturers' logos on them. So quite incredible. So when you're buying your original car parts with Ford, Audi or whatever, you may not be getting a part that's made by Ford, because I don't believe Ford actually make brake pads. Same as Tesco's, they don't have a bean manufacturing facility, do they? Anyway, once again, as usual, I'm waffling and I digress. So what we need to do is fit all this onto the engine. It's all been cleaned and blown off. Don't forget what I told you before. If you're blowing the head, yeah, make sure you're blowing in a clean area. Like if I was going to blow this head off on the bench, all I'm going to do is blow all the crap off the back of the bench forward and then back onto the head. So make sure you do it outside, or just hold it up in mid-air and just blow it off. Make sure there's nothing behind it that's going to blow crap back on. I actually blew out the block and I was amazed. Quite a few little bits and pieces came out of the threads still, you know, so I was amazed after all the work I've gone through, brushing it and washing it and pressure washing it and God knows what, and it still had crap in the thread, in the threaded holes. So yeah, only tiny parts, but amazing. So first things first, the head gasket on these engines is not just, you don't just go and buy a head gasket off the shelf. The first thing you need to do is determine which one you need, and they are actually marked. You can see on here, this one has 2 holes here, and under this label, if I can get it to tip out, there we go, you can see here, oh God, it keeps falling down. You can see here, if I hold the gasket, it's got 2 teeth here, 1, 2. So you get 1 teeth, 2 teeth, 3 teeth, okay? You need to make sure you've got the right one. I guess if you go too big with 3 teeth, all you're going to do is lower your compression slightly. If you go too small, like if you require a 3 and you end up with a 1, you do risk piston to head contact, and you don't want that. Because it's not very good for performance, and it's not good for the engine, and it's also not very good for your wallet either. So the first thing we need to do is determine which gasket we need, and I'll show you how to do that using a clock. And we're going to use a clock because we're looking at quite small measurements, and I don't really trust using depth gauges and stuff for these small measurements. So we'll get back to the engine, which is behind me. We'll get the clock on there and I'll show you what we're going to do. Okay, so to determine our gasket thickness, we need to check how tall the pistons, or how high the pistons come up out of the block. As you've probably seen already, the head face is dead flat, and the piston face is flat with a recess in it where the combustion goes on. So obviously the head gasket has got to take care of the thickness. If you put too thin a head gasket in, or if you can imagine, if you use no head gasket at all, the pistons wouldn't reach top to center, because they actually rise up out of the top of the block, as I shall show you now. You can see they actually come up proud of the surface, which is quite unusual. I don't know if it's common on diesel engines, but it's quite unusual for modern engines to do that. So basically what we need to do is determine how much the piston comes up out of the block, and then we can verify the thickness of gasket we need. So as I've said so many times, if you know all about this stuff, just switch off or fast forward or whatever, because this is all done for those that may not know and might want to know, or just like listening to me talk drivel. So there we go. So what I'm doing first of all, I haven't got the mag base on because it'd make it too difficult to move around. So just got the block here sat on this clock block, sat on the block, the engine block, so clock block on engine block, and then set the clock to 0 on the head face. Okay, so there we go. So we can see now we've got 0 on there, and that's all good. So what I'm going to do is bring this across here, okay, and bring the piston up to its highest point. Okay, so that's going up to, so that's 17 thou there. Now, I've already done this once, and then I'm redoing it because I realised I was showing you wrong. You need to check it in 3 places. So we've got 17 thou there. So I'm going to come over to here. Whoops. I don't know if you can see the clock, but I just need to make sure the clock is down on a flat base. So we'll check it 0. Yes, it is. Lift it up, put it over to there, and I've got 15 thou there. And then you're definitely not going to be able to see this, so I'm going to have to turn the clock around. I'm sorry, but I've got 0, and I've got, just knock something off. What's that there? 15 thou there. So we'll take the highest reading, so that's 17 thou. So we've got to do that now on all 4 pistons and then record what we've got. Now I need to check in the manual. I'm not sure if you take the average or if you take the highest, but this would average out at about 16 anyway. So I need to do this on all 4 pistons, and I'll write down the numbers, and then I'll come back to you and I'll let you know how I got on. Okay then guys, I've just checked the manual. I've measured them all now, and in the manual it does actually say the manual is really difficult to work with because everything is all over the place, and a lot of modern car manuals are the same. You would think they would put all of this information with head gaskets or with pistons, but it's not. It's everywhere. So you need to be careful where you're looking. So basically what we need to do is check it in 3 places, here, here, and here, and then take an average. And the reason you need to do an average is because these pistons, as I showed you before, have quite a lot of rock in the upper area. So you can actually get quite a difference going from here to here. So measure there, there, and there on all 3 pistons and take an average. And that's the way to do it. Otherwise you're going to get, I mean, you've got some measuring as low as 10 and then as high as 20. But then you rock the piston the other way and it changes. So basically just do it like that. As I say, I have checked, everything is okay. There is a lot of movement in the top of these pistons, obviously to allow for expansion. But I know they're okay because you can still see the turning marks. So I know they're not worn. If they were all scraped and polished and everything, then I would be replacing them. But if you go back and look, I didn't actually have any issues with these pistons at all. In fact, if I think of it, I'll put a picture up now of a piston. You'll see that it's not worn at all. So that's obviously just done like that and there's no step in the top of the block. You can see a mark, that's just the combustion where the top ring comes up to. But basically I've done everything, and I've got 0163, this is an Imperial, 0163, 0166 and 0156. So if we look at the numbers, they tell us what we need to be doing. And if you look on here, I've written it down and I've done a conversion. So basically we've got 0.31 to 4, 0.4 is 1 tooth, 0.401, this is metric, to 0.45 is 2 teeth, 0.451 to 0.5 is 3 teeth. Now my highest one was 166, so that's 16 to 17 thou and 7/10. Okay, so I'm in the 2 tooth, so I know that I've got the right gasket. And to be honest with you, I bought the gasket set before I even stripped the engine, so I just used the 2 teeth that was already on there to work that out. So there we go, we need to look at getting this head on now. Okay, so moving forward, so I've just realised I told you to measure the pistons here, here and here. It's actually here, here and here. It doesn't really make any difference because they're going to rock either whatever way. But basically measure the pistons in 3 places. So that's the way to do that. Right, so that first thing we're going to do is, finally we're going to give this head a clean. Remember, your hand is one of the best cleaning products you have. For final cleaning, it is awesome. Just to make sure there's no bits and pieces in there. Make sure you get around those dowels, make sure there's nothing around them. Nice lint-free cloth. Quick wipe around the top of the bores just to make sure nothing's in there. Remember, it has been quite windy of late, so I think, you know, when it's been upside down, I think bits and pieces have got blown up into the bores. But you know, this isn't an engine building room. This isn't the best conditions for building an engine, but it's all I've got. So we're going to get the gasket out of its packet, cut across there. So we can take the gasket. It comes in a bag, in a bag. So this bag is open, so we can get the gasket out. Okay, and it's a multi-layer gasket. It's, as you can see, it's got many layers, and it's also very thick. So it's nice and clean. We know the block is nice and clean, so we can lay this down on here. It's got to be dry. Make sure there's no oils or anything, or sealants. You don't want any of that down there. And then we can just lay the gasket down like that. I'm just gonna, just for a double check, just to make sure, because I didn't check it, did I? I'm just gonna check this side is spotless, and there was a bit of cardboard there, so glad I checked it. And yeah, all looking good. So we can lay this down on here, over the dowels, like so, and that's it. And then we've got to do the same now with the head face. That looks like a piece of dirt there. It's not, it's a minor tiny scratch. I'm going to do the same with this face, make sure it's perfectly clean, all good. Okay, and then we're going to check the head face. I'm behind the camera now, so you can't see what I'm doing, but I'm just, again, using my hand to clean the surface. Okay, and then we can grab the head. Make sure you don't put the head down on any corners or anything on the bench that could pick up any debris. So we grab the head, like so. And then we can lay the head on the block, and what we don't want to be doing is sliding it around too much. So we can feel it going in there. That went down really easy. I was thinking I was going to have to move that around a bit, but that, yeah, that's on now. So the other thing I talked about, when I talked about the head being warped, what I've realised is this corner here, exaggerated, is actually down. So when you put the head on the block, I can kind of get a feeler gauge all the way across this area here. And if I sort of really push down or whatever, it's actually this area here is probably when it's milled, it's pushed off. So that's where my head flatness was coming from. But with a gasket this thick, I don't really think we need to worry too much. So there we go. I was tempted to put some sealant in here, because my other gasket was leaking here, but I don't want to be lifting anything away. So I'm just going to put it together as it is, and then if we do get any leakage, I can put some sealant around there, or just keep an eye on it. I hate oil leaks, I can't stand them. So now we need to move on to the bolts. Okay, so I've got the bolts laid out on the bench, and what I'm going to do, now the threads are already oiled, but the heads look to me to be dry. So what I'm going to do is, with my little brush, I'm just going to put a drop of oil underneath the heads, just so that they don't pick up, because they are going to alley head and you want them to slide on the surface. Ideally, you see, in days of old, when not everything came down to cost, they would have had hardened steel washers which you would lubricate, so you would have the steel bolt or nut, if it was a stud, turning against a hardened steel washer, rather than this, which is just going to be all launching itself into an aluminium head. So again, you know, the accountants have won, and we've got a inferior product. So I'm going to get all these bolts in now. I'll get the camera so you can see me doing that, and then we'll start getting them torqued down. Okay, so as you can see here, we're looking at the computer screen, so you can see there that's our torque pattern and the torque tightenings we're going to go to. And you can see here exactly what I was talking about. They're fairly low. The actual, if you look at the actual readings we're going to, then we're going to go for this massive 180 degrees. And this is because of this, what I'm talking about. If you had a torque of, say, higher than 40, what would happen is the aluminium may start to pick up. So if you can imagine, the friction of the steel bolt against the aluminium may overcome the torque of the bolt stretching. So you'll think you've gone to 50 Newton or 80 Newton meters, say, but you haven't. You've only gone to 60 because the bolt is dragging in the head. So this is why they do this torque and angle thing. So it guarantees they all go to the same amount of pull. So I'm going to get the camera back on the engine now, we'll get the bolts in, and we'll start getting them torqued down. So we've got the larger M10 bolts here. Now I have seen people do this and they just drop them in, and that can damage the thread in the block or in the head, so in the on the bolt or the head. So be very, very gentle with them. Don't just chuck them in, you know, put them in gently, be a bit professional about things. Just drop them in like this. A little bit of silicone there. It wasn't silicone, it was carbon from the exhaust ports. I must say the exhaust deposits you get for a diesel engine are quite disgusting, and then to, you know, add insult to injury, pumping all that back into the inlet is even worse. It's just EGRs. I don't know why these engineers or these people don't think, you know, it's great when the vehicle's brand new, but once it's done a few thousand miles and everything's all clogged up, the engine becomes less efficient and more polluting than if it hadn't had it in the first place. So it all seems a little bit pointless to me. Okay, so now I'm going to go and wind them all in just so they touch. Now, I don't know if you can watch this, you can fast forward or whatever. I'm just literally just winding them in by hand until they touch. This is also another way of checking that your threads are okay. So what we've got to do is that they're numbered sort of 1 to 10. So the bigger bolts here, the 17mm headed ones, they've got to go to 20 Newton meters. So there is a specific tightening sequence, as there always is with cylinder heads, and you're basically going to start in the middle, go 1, 2, 2, 2, 2, okay, as we always do. So I'm just going to get my leg behind the stand so it doesn't roll around. So this is 1. I think before we start doing any pulling down, I'm just going to pull them down so they're all touching. That way you're not, you know, the head gasket is like a sandwich and it does squash. So if you did these up to torque first, you're basically bowing the head, if you like. And I don't want to do that. I just want to bring them all down to just touch, so there's kind of even pressure. Did I do that one? Yes, I did. There's even pressure on them all. Right, okay, so now the gasket is sort of under load. So we can come to 20 newtons on that one. 2. And then we're going to go 3, 4, 5, 6, 7, 8, 9, and 10. And then the next bit is the smaller bolts, the 13mm headed bolts, which are M8 thread, and they're going to be 11 through 20, and they are going to go, 11 through 18, and they're going to 10 Newton meters, which is nothing. So I'll wind this down to 10 Newton meters, lock it up, and then we're going to go, okay, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so that's those done. And then we go back to 1 to 10, and they're going to go up to 40 Newton meters. It's great that we can do it all with this small one rather than getting the big half-inch one out. Okay, so we're going to go back to 1 to 10 on 40 Newton meters. So again, get my foot behind the stand because we're going a bit tighter now. 40 Newton meters. 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And then the 11 to 18 goes up to 20 newton meters. So we'll wind this back down to 20. And then we're going to go 11, 12, 13, 14, 15, 16, 17, 18. I'm just going to check that again because that went quite easy, that one. It was there. This is the thing, when you've got these bolts, if one's a bit more slippery than the other, it'll feel looser, but it's not. It's because of the friction. So now we've got to do all of them to 180 degrees. And I'm not going to film that because I'm going to have to put the engine on its side, I think, and sort of pull on it to get that 180 degrees. So I'm going to turn the camera off now and I'll come back when that's done. Well guys, to be honest, this is actually quite easy. These bolts must be stretching a lot. So thing to do, make sure, if you're new to this, make sure you've got because we have to go 180 degrees. So it's no good if I start like this, because then I need to get all the way on the other side of the engine to pull it. So you want it sort of at a tangent to what you're looking at. So it's kind of at 90 degrees to you. Make sure it's good and solid up to there. And then we can get our foot under the engine stand, get my hand on the side of the engine, and then just in one smooth movement without stopping, you want to keep going, go 180. We'll just do one more. Okay, just like that. So that's up against there, and then we can pull one smooth 180, just like so. That's how easy it is. Another quick little tip for you guys, I don't know if you can see, if I zoom you in, you can see these little paint dots, little dots of Tdci. And what I did, I put a dab of it on every bolt in the forward position, so that when I've done them all, I know they're all done. I can see that now that dot is rear of the engine. So I've got to go around and do these now. These have got 180 degrees. Okay, so here we go, ready to put the cam carrier on now. So head's all torqued down. So we're going to fit the cam carrier, which is the item here, which clamps the cams down. Well, it's the top half of the bearings, and then we've got all the bolts here. Now luckily the blue book, as you all know, has told me all the bolts I need, all in box D, all clean and ready to go. This one isn't dirty, it's actually black. I don't know, it's gone through some sort of chemical reaction with something. So so basically they're all ready to go. I have found an issue with the manual. It tells you here, if you look on here, it tells you all the bolt numbers there, and if you look up on the right, it says here 23 through 25 to 10 newton meters. 23 is this bolt down here, that's actually an M8. It should be 24 and 25. So I would say 1 to 23 is 23 newton meters, and then 24 and 25 is 10 newton meters. So that's something to bear in mind. There's no way that's a main bolt. That's one of these long ones here. That's going all the way down through. That's not going to be 10 newton meters. It's going to be 23. So that's what I'm going to do now. I need to go back to some photographs and work out, because these are 24 and 25, the little M6 bolts, and one of them's a stud, as you can see, and one isn't. So I need to work out which side goes on where. But I've got a load of photographic reference, so I can go back and look at that and see which is which. Okay, so quite a long segment now. So as you can see when you look at that, I've got the red assembly lube in there for the cam bearings. And the manual tells you now to put the sealant on and then put the cams in. Well, I'm going to do the cams first in case there's an issue, because if you find an issue when you put the cams in and the sealant's already down, then the sealant starts drying, and then there you go. So these cams are actually marked, and they've got a number on them here. And this one's got 73 on it. You see the 73 there. And the other one's got 82, and I written down in the blue book, 73 is inlet, 82 is exhaust. Now, I don't know what that number is. It's just a number that's on my cams. But I also noticed they've got US patents on them and stuff, but they're these typical modern crap, you know, pressed together cams with sintered lobes. Ugh, horrible things. So it doesn't matter how they go, because one good part of the design of this engine is you bolt the the rocker arms on afterwards, so you can put these cams in how you like and it's not going to affect how the valves are with the pistons. And also, yeah, 73 is inlet, 82 is exhaust, so 73 is here. So this is the inlet side. Make sure they go in square because you can actually snap these corners off if you're not careful, so be very careful. I've seen that done on other engines before where people have snapped them off and then had them welded up, so make sure it all goes in nice and square. Don't force it, okay? That's how you want it to go. You can imagine if you put it in like this and then like that, you're going to break the casting. So that's going to drop in there like so. Make sure it drops in easy, there we go, so it's nice and square. I'm not going to give it a turn because I don't want to lift the oil up onto the surfaces. So now that that's done, we can put a bead of silicone around and get ready for putting our cam box on. I'm going to use this. This is the Wright's stuff that came with the gasket set, and they're asking for a 2.5mm bead. And my engine actually leaked here, so I'm going to make sure I get a good bead along there. And I have checked, the cam box is actually right on the back edge, so we need to make sure that we get our silicone on that back edge. So I'm going to come across the front here. Okay, we're in this bolt, like so. We're going to go along here, around that bolt, and along here. This must be like make sure to stay on that back edge because it's a very thin section. It's on there, it's not very wide at all. And there we go. So we can drop the cam box on. There's dowels on this, which is surprising judging by the rest of this engine. So it's going to drop on just like that. Check we've got sealant oozing out everywhere. I don't see anything oozing out on this side. Yes, there is, that's okay. Okay, so we can drop all the bolts in. So once again, I'm going to oil the heads and the threads. Okay, so these two long ones go in here. So that's all good. Okay, so got that on now, that's all torqued down, and I've gone round and I've checked, I've got silicone oozing out of every single area. There's no gaps. If there's any gaps, it's probably best to take it off again and make sure that there is silicone there, because you know, once you get oil leaks in this area, it's a big job to get the injectors out and everything to deal with it then, so you're better off dealing with it now. That's why I tend to go back over things and make work for myself, because I just want to be sure, really. So the manual now talks about fitting the cam pulleys, which seems a little strange to me, but you know, I would have thought, sorry, fitting the cam pulleys is fine, and then they talk about putting the rockers in, which seems a bit strange to me, because I would have thought we would time it all up without any risk of hitting the pistons and then do it all afterwards. But I'll follow the manual, even though it's probably wrong. So you can see I've got the pulleys here. Now before I took them off, I marked them, and I marked them with an EX and an inlet. I don't need to say what that means. And with these engines, you tie them up with a couple of 6mm pins, and I've got a couple of 6mm drills here, and there's a hole in the aluminium. If I bring the camera down, you should be able to see it. There's a hole here in the casting, you can see behind that slot. Basically this drill is going to slip into that slot and then into the hole, and the same on this side. There we go. And now the cams, as you can see, are locked, so the timing's good, will be good, so we can leave those in there for now. Then we come along with our pulleys. We drop them in. So this one's the exhaust, so the drill's going to go through that hole there. that one's going on that way. And then this one's jaw's going to go through there, so that one's going to go on that way. Okay, and then the bolts are going to go in here just loosely for now. And I'm actually thinking I may need to take this pulley off again to get the chain over it, because it's very tight there. But we shall see. I'll just put these bolts in finger tight in case it does go over. You can see that what this does, it allows us to move the pulley without actually moving the cam, which was always an issue with cam belts, especially with the twin cam. You could never get them to line up perfectly if you had solid pulleys. What this enables you to do is, if the chain doesn't quite work out exactly to the timing marks, then you've got that movement there. So the coloured link on the chain is going to go above that arrow and above that arrow. So if the chain is slightly that way, it can be that way. If it's slightly that way, it can be that way. But the cam timing is still not altered. So it's a good thing with modern engines, we do get this adjustment in them. So there we go. So that's those bolted up loosely. I'm not going to put the chain on yet, because that's going to be the next video. We're going to fit the fuel pump, and we're going to do the cam timing, and we're going to put the actual rockers in as well. Okay, so thanks for watching, and I'll see you all soon for part, what was it going to be, 11? As I say, we'll put the rockers in, put the fuel pump in, put the timing chain on, time everything up, get all the chains all locked down. That'll be part 11. See you for that. Bye for now.